partial fraction decomposition, section 8.5, number 15. 1 over x squared plus 1. I really can pick up all your stuff in a bit. You don't have to turn it in now. It's fine though. Okay, so this one's going to be a constant factor over the a constant numerator over the linear denominator, correct? And then a linear numerator over a quadratic denominator. Okay, so there's the setup. Now we multiply by the least common denominator.
Oh wait, so my question is, why is it bx? It's just bx because that's just like...
That's the rule. Yeah. Anytime you have a quadratic factor, you have a linear numerator. Linear factor, constant numerator. That's just the rule. Okay, so then we multiply by the least common denominator. So this denominator would cancel out completely when we multiply by x squared plus 1. This one, when we multiply by x squared plus 1, would cancel the x, but we still have the x squared plus 1. So we'll have 1 over here, and then a times x squared plus 1. Then this one, if we multiply by x over x squared plus 1, we cancel the x squared plus 1, so we just have an x, so it's going to be bx plus c times x. Okay? So now we need to choose a method to solve this. I don't think we're going to be able to entirely do it by the convenient x method because there's nothing to plug in for x here to get rid of a. And also, if we plug 0 in for x here, it gets rid of b and c, and then we can just solve for a. So we could do that. That might be a valid thing to start with, but it's not going to get us finished with this answer because we still won't have b and c. So we might want to just do it by lining up the correct terms. Is that okay if we just do it the whole problem that way? Okay, so I'm going to distribute first before I line up my correct like terms. So first I've distributed this and I've distributed this, correct? Okay, now on this side of my problem, what x squareds do I have? Anything? On the left, any x squareds over there? No, so we call that 0. On the right side of my problem, do I have any x squareds? I do. Ax squared plus bx squared would add up to the 0 that's on the left. So we just do a plus b. We don't actually need the x squareds. We were just looking at the x squared terms to create that. Then we look at the x terms. Again, on the left we have 0. On the right, all we have is c. That means c equals 0. And then as for the constants, it doesn't even really matter because all we end up with is 1 equals 1, which is true, thank goodness, but there's no variables involved in that one at all. Okay, so at this point we know c equals 0, and I think a few minutes ago we determined that if we used the convenient x method, we could use that to find a. Because right now we don't know a or b, and so we can't go from here without knowing one of them. So I'm going to go ahead and default to the other method, which is let's let x equal 0. So then we're going to plug that in to this step right here. We're going to plug that into this step, okay? So that gives us 1 equals a times 0 plus 1 plus b times 0 plus c, and that entire thing multiplied by 0. So that ends up just going away, right? Excuse me. So then we end up with 1 equals 0 plus 1 is 1, so 1a. So does that mean a equals 1? So then we can plug that in here. If A equals 1 and B has to equal something so that they add up to 0, what does B have to equal? Negative 1. Okay, so there's A, there's B, there's C. We can now write our answer. So we're going to have A, which is 1, over x, plus bx plus c, which is going to be negative x, negative 1x plus 0, so I don't need to write that part, over x squared plus 1. And that should be the right answer. Anyone check it in the back? Did it work out?